Hey guys, so welcome to our last video. You made it, okay? Uh, I want to congratulate you, feel proud about the knowledge that you have gotten, okay? And today we're gonna be solving problems that are a little bit more complicated, okay? Why are these problems more complicated? Well, basically because we're going to be combining concepts that we already studied, and that is what makes these problems a bit more complex. But no worries, you are ready for that. Okay, so in a bit we're going to see that. Welcome to our last video of the arithmetic series set. As I mentioned it, this is going to be our last video, and what I want to bring to your minds is the two formulas that we learn for arithmetic series, but also the formula that we learned for arithmetic sequence. We are gonna need it. Okay, so I'm gonna write them. Okay, so remember that the formula for arithmetic sequence is un equals u1 plus n minus 1 times t. Okay, also, remember, so this is for sequence, okay? Remember that for series, we have two options. We have this one, which is n over 2, 2u1 plus n minus 1 times t. And we have the other option, okay, which is Sn equals n over 2 times u1 plus un. Okay, and what you need to remember is that the second one, we're going to use it when we have the last term. Okay, when we do not have the last term and there's no way to find it out, what we're going to do is we're going to be using the first formula. Basically that. In the first formula, what you need to remember is that the only requirements that this formula need are the first term and the common difference. Basically that. Okay? So something else that I'm going to be adding, and I'm going to be showing you that here, you're going to supposed to be seeing that, is that we're going to be adding two other concepts. And basically the idea is that the first term is equal to the sum of the first term. Okay, so in other words, u1 equals s1. Okay, that is the first thing. The second thing is that u2 is the same that s2 minus s1. Okay, and if we think in this idea as a general idea, every time that you want to find un and you have the sum until that number and the sum until the number before to that one, basically you only need to subtract. So in other words, un equals Sn minus S sub n minus 1. Okay? We're going to see that just in a bit, so no worries. Okay? I wanna clarify that idea because I think that is very important. Okay, so for example, suppose that I want to find u15. Okay, if I want to find u15 and I have s15 and I have s14, I only need to subtract them. So in other words, u15 is going to be equal to the sum until the 15th term minus the sum until the 14th term. That is basically the idea. Okay? So try to get this concept and let's see the first example. Most of the problems that we're gonna solve here are problems that require also simultaneous equations. And why is that? Remember that we need simultaneous equations when we need to find the first term and the common difference. Okay, so in other words, we're going to be combining all the concepts that we have seen in the first very video until this one, which is the last. Okay, let's go to the first example. So, first example, they are telling us that in an arithmetic sequence, the sum of the first n terms is given by that expression that we have here. So I'm going to copy that expression. So Sn equals n to the second power minus 10 times n. And notice that they are asking me to find the term that is located in the 103rd position. Okay? So I already know that in this expression that we have here, I can find the sum of all the values by just replacing the position I am interested in. Okay? We learned in the formula that I showed you before that if I want to find the 103rd term, what I need to do is just find S, or the sum, until that term, and then subtract the sum until the term before it. Okay, so in other words, U103 equals S103 minus S102. Okay, so I need to find first S103. I'm gonna use, let me put this apart because this is the idea, and I'm gonna find first S103. Okay, so to find S103, I just need to replace n by 103. Okay, so notice that that is what I did. Okay, I'm just gonna substitute in my calculator 103 to the second power minus 10 times 103, and that is 9,579. And now I'm gonna find the 102nd term. Okay, so 102 to the second power minus 10 times 102. Okay, so 102 to the second power minus 10 times 102. And that is 9,384. Okay, so now what I'm going to do is I'm going to use this idea that we have here. Remember that S103 minus S102 is going to be U103. Okay, so 9,579 minus 9,384. Let's subtract that. That is 195. So the 103rd term is 195. Okay? That is how we can use this new concept of subtracting two consecutive sums in order to get the last term of the sum. Okay? Let's go to the next example. The next example says, the arithmetic sum of the first n terms is given by that formula that is there. Find the first term and the common difference. So again, we need to remember what we just learned. We learned something. We learned that U1 equals S1. So the formula that they are giving me is this formula for the sum. If I want to find S1, I just need to replace n by 1, and that is going to be U1. So that is what I'm going to do. Okay, so let me write first the formula. Okay, so the formula that is given is Sn equals n over 2, 5n minus 11. Okay, so because I want to find U1, what I need to do is I need to replace n by 1 in the formula. So S1 equals 1 over 2 times 5 times 1 minus 11. Okay, so let's input this in our calculators. I'm going to show you how I am going to do it. So here it is. I'm going to use parentheses to set the fraction apart. Okay, so 1/2 times 5 times 1, which is 5, and then minus 11. Okay, that is -3. So notice that the first term is -3. Now they are asking me for the common difference. Okay, remember that the common difference could be found when we subtract two consecutive terms. I already have the first term, so if I want to find, if I can find the second term and I subtract the second minus the first, I'm going to get the common difference. To The only tool that I have, or the only information that I have, is the formula of the series. So I need to use it. And what I'm going to find is S2. Okay? So by substituting n here by 2, instead of writing n, we're going to write 2. Okay? So this is 1. This is 10 minus 11. And this is negative 1. So S2 is negative 1, but be careful, S2 is not equal to U2, okay? S2 is the sum of the first and the second term, okay? So S2 is equal to U2 plus U1, okay? I know that S2 is negative 1. I do not know U2 because that is what I'm looking for. And I know that U1, which I found previously, is negative 3. Okay, so I just need to solve this, passing the negative 3 to the other side, adding. And what we're going to find is that U2 is 2. Okay, so U2 is 2. U1 is negative 3. But remember that the question is, what is the common difference? And I need to remember that to find the common difference, what I need to do is subtract U2 minus U1. So U2 minus U1. Okay, so U2 is 2 minus negative 3. Be careful here. This is basic arithmetic. Negative times negative, that is positive. Okay, 2 plus 3, that is 5. So the common difference of this sequence is positive 5. Okay, so let's answer the questions. U1 is negative 3. The common difference is 5. Okay, notice that in this simple problem, we had to use many concepts that we learned previously. Okay, there are two more problems that we're going to be solving today. Okay, let's go to the third one. It says an arithmetic sequence has a third term 11. Okay, so U3 is 11. Okay, and the sum of the first 10 numbers is 160. Okay, 160. And it says find the first term. So in other words, they are asking us for U1, and find the common difference. Okay, and also find the general expression UN. Okay, notice something. I already know that this problem is or is going to be solved using simultaneous equations. How do I know that? Because there are two variables that I need to find. Okay, and actually those two variables are embedded in the formulas that I have here. So what I'm gonna do is I'm gonna be working with these two values, U3, which is equal to 11, and S10, which is equal to 160. But first, I need to work with them apart. So I'm going to be setting the two equations that I'm going to be using. Let's work first with the third term, okay? Because they are talking about terms and not sum, we need to use the formula for the arithmetic sequence. Okay, so UN equals U1 plus N minus 1 times T. Okay, and what I'm going to do is I'm going to replace the only information that I know. I just know two things from this formula. One, I know the N is 3. And the other is the value located at that position. So U3, which is 11. Okay, so I'm going to replace that. 11 is equal to U1 plus, and N is 3. 3 minus 1 is 2. 2D. Okay, so notice that I already have the first formula. I'm going to arrange it. I'm going to write the variables in the left side. So U1 plus 2D equals 11. That is the first formula. Let's keep it here. I'm going to write here that it's the first equation I'm going to be working. Now, let me minimize this because I need more space. Okay, I'm going to change the color. So it could be, I can differentiate them. Okay, now I'm going to work with the other information that is given, which is the S10. Notice that because they are talking about the sum, I need to work with the formula of the series. Okay, so I'm going to be working with S10. Okay, and here I do not have the last term of that sequence. So because I don't have the last term of that sequence, what I'm going to be using is the first formula of the series, okay, or the first option. And I know that that formula is Sn equals n over 2 times 2u1 plus n minus 1 times t. I know that S10 is 160, and I know that N is 10. So 10 divided by 2 is 5. 2u1 plus 10 minus 1 is 9, 9d. Okay, so 160 equals 10u1. Notice, remember that this 5 that is here is going to be multiplying each of the elements inside of the parentheses. So 5 times 2 is 10, and then 5 times 9 is 45d. And notice that this is my second equation, and that is everything that I needed. Why? Because the questions are two variables, I need two equations in order to use simultaneous equations. So what I'm going to do now is I'm going to be putting in my calculator these two equations using the app that the calculator has for simultaneous equations. Okay, so let me just first arrange these two formulas so they are clear of, and we are clear of what I'm gonna be writing or typing in my calculator. Okay, so these are the two formulas that are going to form my set of simultaneous equations. Remember, let me clean the calculator here. Remember that to input these formulas in the calculator, we need to go to the key that says apps. Okay, let me focus better here. And in this key that says app, we're going to select the 9th option. Okay, here I have the main menu, and I'm going to be working with the second option, the one that says simultaneous equation solver. Okay, the calculator is going to ask me how many equations I have. I have two equations. How many variables or unknowns values I have? Two also. Okay, I need to press next. Remember that these tabs that we have here are connected with these keys that are here. So if I need to press next, I need to press this one that is here, the one that says graph. Okay, now I need to type my equations. Okay, the first one is u1. Remember here, u1 is going to be x, and d is going to be y. Okay, so u1 or 1x, okay, 1x plus 2y equals 11. Okay, let's input the second one. 10x plus 45y equals 160. Okay, so we already input the values. We need just to press solve. Okay, so here we have the answers. X, remember that x is u1, so that means that u1 is 7. I'm going to write here u1 is 7, and d is 2. Okay, so I already found the first term and I already found the common difference. Now I'm going to write the general expression for each term of the sequence. So I need to bring back, I'm going to change the color so it's not misinterpreted. Okay, so un equals u1 plus n minus 1 times t. Okay, so un equals u1, which is 7, plus n minus 1. Remember that the general expression is in terms of n. Okay, so I'm not going to replace n. I'm going to write everything, and at the end, the expression is going to have n always there. Okay, so the common difference is 2. 7 plus 2n minus 2, and now I just need to simplify. Okay, so 2n, 7 minus 2 is positive 5. Okay, so this is question A, this is question B, and the expression is question C. Okay, so basically, this is how we use the concepts, all the concepts that we have been learning. First, the arithmetic sequence, arithmetic series, and simultaneous equations, all in one. Okay, so we arrive to our very last problem. Remember that this problem is the problem that you're going to pause and you're going to try to solve it. Okay, so I'm going to read it. When I finish reading it, please pause it, and then we're going to see the solution of it. Okay, so it says, consider the sequence S sub n equals 2 times n to the second power minus 3n. Find an expression for the general term un and show that this is an arithmetic sequence. Okay, so pause the video, solve it, and then come back to check it out. Okay, welcome back. I hope that you were able to solve this problem. Now we're gonna compare our answers. Okay, so I already took notes about the problem. Okay, so they are giving me the expression of the sum. Okay, and notice that the question says find an expression for the general term un. Basically, what we need to understand is that with this expression s sub n equals to 2n to the second power minus 3n, what they're asking me is to find the general expression. And to answer the general expression, I need the first term and the common difference. Okay? Remember that the first term equals to S1. Okay? So that is what I'm going to do. I'm going to find first the first term by replacing n by 1 in the formula that is given. 2 times 1 to the second power times 3 times 1. So with this, we know that this is going to be 2 minus 3, negative 1. U1 is negative 1. I already found U1. Now I need to find the common difference. How? Well, finding the second term, because the common difference is the subtraction of two consecutive terms. Okay, so I need to find S2. Okay, S2, basically I'm going to find it by replacing this formula, or in this formula, n by 2. Okay, so it's 2 times 2 to the second power minus 3 times 2. Okay, this is 4, 8, and this is 6. So 8 minus 6 is 2. So notice that I already found S2. Be careful. Okay, don't make the mistake of saying that S2 equals U2. That is incorrect. Okay, remember that S2 is the addition of U2 plus U1. Okay, so S2 is U2 plus U1. Okay, and we know that S2 is 2. U2 is what we are looking for, and U1 is negative 1. Okay, and now I'm gonna solve this formula. 2 plus 1 to this equation. Okay, so there you go. U2 equals 3. Okay, so I already found U2 and U1. I'm able to find the common difference. Why? Because the common difference is U2 minus U1. So 3, and the first term was negative 1. So 3 minus negative 1. So it's 3 plus 1, that is 4. Okay, I already found the common difference. I already have the first term. I'm able to write the general expression. Un equals U1 plus n minus 1 times d. Un equals U1, which is negative 1, plus n minus 1. Remember that I do not need to replace n because the general expression is in terms of n. Okay, and the common difference is 4. Okay, I need now to simplify this expression. Negative 1 plus 4n minus 4, un equals 4n minus 5, and this is the answer. Okay, now the last question says, show that is an arithmetic sequence. If this is an arithmetic sequence, the common difference is the same for all the values. Okay, so let's see if that is true. Okay, if we are right, the first term was negative 1. Okay, so negative 1. We said that the common difference is 4. Negative 1 plus 4, that is that is positive 3. Okay, now positive 3 plus 4, that is positive 7. If we are right, and I replace that in the equation, let's replace u3 here. 4 times 3 minus 5. This is 12 minus 5. This is 7. So, yes, it is an arithmetic sequence because each of the terms, of the consecutive terms, has the common difference of 7. With this, we already finished our set of videos about arithmetic sequences and series. Remember to go to the link that is below, find the practices, also the slides, practice as many problems as possible so you can master this, okay? And I really believe that you're gonna get it. Don't forget to subscribe. Don't forget to give a like to this video so I can continue making them. And well, see you in the next set of videos for our next concept. Adios.